screen. Nice to get a bit of a response. Okay. So for the homework I corrected, most people were kind of pretty much there. Be able to well, I think question 14 caused a bit of confusion just because it was going back to the quotient rule rather than the other ones. Yeah. So do you want me to go through any other ones or just go straight to 14? Anyone? Okay, we'll have a quick look at 14 and then I'm going to show you how to kind of do it a little bit quicker because we're going to move on to more complicated functions. So we want to be able to apply the chain rule and the other rules a little bit more efficiently. So I'll go through 14 and then we'll go back over how to kind of do the chain rule quicker. So you've got 4x squared plus 2xy equal to 5. Express y in terms of x and then find dy dx. So we can't find dy dx at the minute because y is kind of stuck there with that 2xy. So when you're expressing one term in terms of another, you want to isolate it. And when you're trying to isolate a variable or rearrange a formula, best to do the order of operations in reverse. So if there's adding or subtracting to be done, you do that first. So we're going to take away 4x squared from both sides, which leaves us with 2xy is equal to y, 5 minus 4x squared, or some of you might have had that the other way around. It doesn't really matter. And then we're going to divide by 2x, y on its own there. And when we're dividing in algebra, it's very easy because you just make the divider the denominator. Okay, so now y is in terms of x. We cannot simplify that. There is no common factor. There's nothing that goes into everything on the top and everything in the bottom. You can only simplify fractions if there is a common factor, and there's not here. So when it's a fraction, otherwise known as a quotient, we apply the quotient rule, which means we have a u on the top and a v on the bottom. So the u is 5 minus 4x. V is the bottom, which is 2x. Differentiate u, affecting x, you bring down the 2, you've got minus 8x, and then v prime is just 2, bring down the 1, and then that becomes 0. And then our formula for the quotient rule tells us dy dx is v u prime, which is this one. So that's 2x by negative 8x minus u by v prime, which is these two, all over v squared, which is 2x in brackets squared. So when you're multiplying out, remember your SNL. So you've got minus by plus is minus, numbers are 16, and x by x is x squared. Minus 5 by plus 2, that's minus by plus, and 5 2s is 10. Then minus by minus is plus, 4 by 2 is 8, and the letter is x squared. All over 2x in brackets squared. And then we can combine the x squared. So you've got minus 8x squared minus 10 over 4x squared, if we multiply this out. Now this I can simplify because 2 goes into 8, it goes into 10, that goes into 4. So it is a common factor. So if I divide everything by 2, then I've got minus 4x squared minus 5 over 2x squared. And you can leave it like that, or you can even further simplify it. There's no real need, but if you wanted to, you could split it up into the 4x squared over the 2x squared and this. So that would be minus 2, because there's minus 4 over 2 and the x squared cancels, and then minus 5 over 2x squared. But I wouldn't really go as far as doing that. Okay, usually in calculus, we just leave it as a fraction. Is that okay? So the rest of the questions in this are going to be mixes of the quotient rule, the product rule, and the chain rule. So I just want to go back to the chain rule first before we go on to show you how to do it a little bit quicker. So if you remember, what we were doing was writing out, identifying u, writing it over at the side, and then changing y into a power of u or some function of u. And then we do the two of them and we multiply them out. Okay. So what I want to do is show you how to kind of avoid having to multiply to kind of write all the u's and v's out. So if we take example, or even just before example 4, at the top of page 282, you've got 2x plus 5 cubed. Sorry, I'm just going to write it down and then I'll... Okay, so what would you be here? Yeah, that's u cubed, and you would be... Yeah. So we know we have to differentiate the u cubed, if you like, and then multiply them. Okay, so there's two functions going on here. There's what's in the brackets, and then that gets cubed. Agreed?
Okay.
So rather than have to multiply it all out, now that you've had a bit of practice doing this, what we can do is we look at what's in the brackets first, and we write down the derivative of that. So 2x plus 5, ignoring the second function, which is the cube, the derivative of this is 2. And then I kind of ignore that and look at the other function, which is a cubed. So if I have something cubed, I know I bring down the 3. So I'm just going to do that. Then I still have what's in the brackets, and then the power will reduce to 2. Okay? And then I can multiply that out and just get 6 times 2x plus 5 squared. So if we go back, and if we'd done that the long way around, we'd have u prime is equal to 2. We'd have y prime is equal to 3u squared. And then we'd have 2 by 3 is 6 by u squared, which is what we got here. Okay, so what you have to do is identify the different functions, differentiate one function. So we're differentiating the 2x plus 5. Then we're differentiating the cubed, which means bring down the 3 and reduce the power by 1. So bring down the 3, reduce the power by 1, and whatever's in the brackets still stays. Okay? So it saves me having to go through all this part. So another example, say y is equal to 4x squared minus 2x plus 7, the power of 5. Okay? I look at what's in the brackets, that's my u. So if I differentiate just what's in the brackets, I would have 8x minus 2. Is that okay? Yeah. That's my u prime. And then the other function is the power of 5. So I bring down the 5. I still have my brackets, and I fill them in. And then the power goes down by 1. Okay, so I'd have u to the power of 5, which is 5u to the power of 4, and then I have du dx, which is 8x minus 2x. And then I can multiply that out, so I've got 40x minus 10 times all of this to the power of 4. And you want to get used to doing this, because at the minute we're just looking at algebra as our function here. We're going to be moving on to look at sine and cos and exponential and logarithmic, all sorts of other different functions. So we need to be able to do this so that we can apply the chain rule easily enough. Okay. So let's go through the other examples that are in the book. So see, I'm just doing number 2 here before we get to actual example 4. So we do x squared minus 3x. That becomes 2x minus 3. So that's, they're kind of doing that second. And then the power of 4, you bring down the 4 and you change that to a 3, the new power to a 3. And what's in the bracket, that the input to the second function, in other words, what our u is, does not change. So what's in the bracket stays the same. The x squared minus 3x stays there. Its power changes to 3, it gets multiplied by 4, and then it also gets multiplied by its own derivative. Okay, so the order you do it in doesn't really matter. You can do the 4 first, bring down the 4, change the power to 3, and then you have to derive what's in the brackets. I would tend to do what's in the brackets first, because people kind of forget about that. So derive what's in the brackets, then derive the second function, which is your power of 4. So they then do that one, that's actually part of example. They use that in example 4. And then the second part of example 4, you have the square root of x squared minus 6x. So I would first put that into the form that I know how to derive. So at this stage, we kind of know that's 1 over 2 root, whatever. So if I derive what's in the brackets first, I get 2x minus 6. Okay, bring down the 2 and then power of 1. Okay, is that all right?
Mm.
And then I ignore that and focus on the power. So I bring down the half, I've got my brackets, which aren't going to change. And then I take away 1 from the new power. And then I'm going to simplify all of that. So I know the minus a half means it's going to be the square root of x squared minus 6x. And then I can multiply a half by 2x is just x, and a half by 6 is minus 3. And then some of our other questions that we're going to look at are going to be a mix, as I say, of product and chain and quotient rules. So if we look at example 5, you've got x over root 1 minus x. So that's straight away, it's the quotient rule. But for this little bit here, we're going to have the chain rule. Okay? So u is equal to x and v is equal to 1 minus x to the power of a half. Okay? So I would still, for the product rule and the quotient rule, I would definitely write out my u's and v's. It's just for the chain rule, we want to be able to do it without having to write out the u's and v's. So u prime here, or du dx, is equal to 1. Is that okay? V prime, now this isn't a plain x, so I have to differentiate first what's in the brackets. So when I differentiate 1, I get 0. When I differentiate minus x, I get minus 1. So that's the bracket sorted out. And then I bring down the power, that's 1/2 times what's in the brackets doesn't change, and then my power goes down by 1. So if I simplify that, I've got minus 1 over 2 times the half brings it underneath, and it means, or the minus brings it underneath, and the half means square root. And now I apply the quotient rule, which tells me it's v du dx. So that's root 1 minus x, or 1 minus x to the half, minus u dv dx. So that's a bit of a nightmare, but it's this by this. So it's minus x over twice root 1 minus x, all over v squared, which is, when you multiply that out, you're just going to get 1 minus x because it's the square root squared. Okay, so root 1 minus x squared is just equal to 1 minus x. Okay. Now, to simplify this, we need to put it over the same denominator. So we've got 2 times root 1 minus x times root 1 minus x, which is just 2 times 1 minus x, because again, we've got this by this is itself squared. So that's just 2 times 1 minus x, minus the x over, this is the denominator, 2 times root 1 minus x times another 1 minus x. Okay, so that denominator on the top can get moved underneath to combine with this denominator. So the 2, this is multiplied by this as well. That's your full new denominator. And then we multiply out the brackets. You've got 2 minus 2x minus another x over 2 times root 1 minus x times 1 minus x. And that's 2 minus 3x over 2 times. And you could leave it like that, or you can do, that's to the power of a half. That's the power of 1. 1.5 is 3 over 2. Now, I went through that to show you all the algebra. However, if you look at the question, it's actually saying evaluate dy dx when x is equal to minus 3. So we could have just stopped here and plugged in minus 3 all over the place, which would get a little bit messy. So it is probably easier to do it here. And they have, now why is it 2 times 1 minus x plus x. What did I do wrong there? uv, okay, sorry, it was minus. Okay, so it's vu prime minus, I missed the minus 1 there. So that should have been a plus x here. That's a plus x here, and that just becomes 2 minus x. Okay. And now we sub in negative 3 for x. So we're working out dy dx at x equals to negative 3. So you've got 2 minus, wherever there's an x, you change it to negative 3 over 2 times 1 plus 3, because it's 1 minus negative 3, to the power of 3 over 2, which is 5 over 2 times, that's 4, square root of 4 is 2, and 2 cubed is 8, that's 5/16. You can put that into the calculator, just like that, and sub in, or even just like this, and sub in your values of x. So do you want to start trying them yourselves, or would you like me to go through another kind of complex example before we move on? Sure. I'm just going to look for a question over here. Okay, number 15, okay? So this is another quotient rule. So 15 says y is equal to x over. So the first thing you want to notice is, do I need to use the chain rule or the quotient rule? And then when you're doing your u's and v's, do I need to use the product or the quotient rule? And then when you're doing your u's and v's, you may need to be doing the chain rule as well. So this is quotient because it's one thing divided by another. So u is the top and v is the bottom. And I would rewrite my root as a power, okay? But I'm doing that because we're still in the early stages. If you're confident enough, you can just leave it like that, because by now we kind of know it's 1 over 2 root x. But if you want to go through it step by step, you can keep doing this bit. U prime is equal to 1 because I bring down the 1 and I have 1 times x to the power of 0. B prime, the 1 will disappear, and that's going to be 1 over 2 times x to the minus 1 over 2, which is 1 over 2 root x. Okay? As I say, we can skip this bit now, but if you do want to do that way, it's x, half times x minus a half, and then that becomes that. Okay? You should by now be able to go straight from here to here. Then we apply the formula, quotient rule formula. And remember, these are all in the tables on page 25. Yeah. Okay. Product rule, quotient rule, that's what we're doing, and the chain rule. And so it's bu prime, so it's just root x plus 1, because that's just times 1, minus, and when we're multiplying a number by a fraction, the number becomes a numerator and the denominator stays where it is, all over the square root of x plus 1 b squared. And I wouldn't leave a fraction in the numerator, so I want to tidy all this up. So I have to multiply both of these by 2 root x. So root x by 2 root x, the number is still 2, and root x by root x is x. Then plus 1 by 2 root x is 2 root x. And then I have the minus x. My denominator is 2 root x, and that can be combined with the root x, right, plus 1 squared. And then I can combine my like terms. I have 2x minus x is x plus 2 root x over 2 root x times root x plus 1 squared. And we want to evaluate that at x equal to 1. So that becomes 1 plus 2, because root 1 is 1, over 2 times 1 times 2 squared, which is 3, over 2 by 4 is 8. And that's the slope of the tangent when x is equal to 1 of this curve. Okay, so I want to get you guys practicing on this. The good news as well is the next little section is very easy. That's the second derivative. And then after that, we'll be moving on to more complicated functions. So we're just going to practice some more of these for now. So question 11 is going to be a combination. Question 13. Question 18. 19. and 20. Okay, so you can get started on those now and see how you're getting on. Ask if you're stuck. Sorry. So 11, 13, 18, 19, 20. And I'm going to take the roll and stick that up in classroom. Everyone doing okay?
Yeah.
Ask questions. And I think I think we went through, I put up the details of the test as well. So it's basically 4 chapters. And I put up notes, some of the notes, I'll put up the rest of them when I get a chance. But I want to try and get this chapter finished next week anyway. So you should be revising away yourselves. But ask me if there's anything that you want a kind of reminder on or want me to go over. Okay, guys? Let me know if you want me to go over any of them. Yeah.
The quotient for the chain rule.
Always start with the quotient. The chain rule is just a kind of byproduct of when you're doing, like, because u is actually a composite function there, you will have to do the chain rule when you, so the chain rule will be what you're doing when you're working out your u or your v, or maybe both of them. But before that, it's either going to be quotient or product. So that's what your first focus. But then you may have to use the chain rule as part of that. So you'll have to use the chain rule when you're doing the u dx there. Okay, but u will be 2x minus 1 squared, and then that's a composite function, so you need to use the chain rule for that, and v is 3x plus 4. Are you checking your answers as you go along, lads? Are we doing okay? guys, class is, we have a few minutes left before I head off. Do you want me to go through anything? And going through any of those? Should be okay. Right. I'll do up videos for them anyway and put them up. And don't forget to study for your tests as well. All right, have a good weekend, and I will see you Monday.
Thank you.
Okay, take care.